Hello everyone. In our previous video, we introduced a fantastic character consistency model called stand-in, developed by the WeChat team. We've already had a direct understanding of its generation quality and character consistency performance. However, there's a crucial point not to overlook. Stand-in is a lightweight, plug-and-play model. It can be seamlessly combined with other LORA models and downstream technologies like VAC to achieve even better results. So, I conducted some experiments to see what effects stand-in could achieve when combined with other technologies. Today, we're going to explore an advanced application of stand-in, collaborating with VACE to create stunning videos with character consistency. Let's take a look at some of the final generated results. You'll see that these videos are all of very high quality. Beyond excellent video quality and character consistency, the core lies in its integration with VACE technology, which allows for controllable character movements. This is quite powerful. Regarding VACE, we know that in addition to its role in main body generation, it has another very important function, controlling character movements, much like ControlNet. Therefore, by using VACE's control mechanism, combined with stand-in's character consistency features, we can produce these amazing videos. So, how do we do it? Let's take a look. Now, let's examine the impressive performance of the stand-in plus VACE workflow we're discussing today. First, I want to clarify that this workflow was developed through my own exploration. There are no other existing workflows serving as a direct basis. So, if you find any shortcomings, please feel free to provide feedback in the comment section. Or, if you find others using similar techniques, I can only say it's a pure coincidence. Without further ado, let's quickly analyze this workflow. The changes in this workflow are not extensive. It primarily involves adding the VACE component. First, let's look at model loading. Our main model is still 2.1 T2 V14B. We added an acceleration LORA. Model compilation technology is enabled. Block swap is enabled, but I've set it to a higher value. The number of blocks is set to 30, while the default is usually 15. Crucially, we've integrated stand-in, which exists as a LORA model. We covered the function of this model clearly in the previous video. I've also added the VAC module, which is loaded here. In KGOD's workflow, VACE is loaded as a module. Important note for VACE model loading. When loading the VACE model, you must load the one for BBF16 version. There are many similar models, including FP8 versions, even 4 modules. Loading other models can sometimes lead to errors, so ensure you load the one for BBF16 version. This is critical, otherwise, your workflow might not run. Next, we use setBlockSwap to place the blockswap node. Then, setLORA is used to merge the LORA with our main model. We also loaded the text encoder and VAE, which are standard. Now, let's look at the VAC part. I've used the simplest video control technique here. Of course, VACE offers many control methods, such as start and end frames. For this demonstration, we'll focus on the simplest video control. There are some basic configuration items that I won't detail. I have a video with a very long frame count, but I only loaded 81 frames. After loading, notice that I used an aux preprocessor. The processing model I used is DW Openpose. Its resolution is set to 768, and there's a resize operation to align it with our required resolution. After that, I previewed it, and you can see it's a pose map with facial information. Then, through our VACE encode node, it's encoded into a VACE vector. This part is essentially the same as other workflows. Next is the stand-in part. Similarly, we have a reference image. Through the stand-in preprocessor node, a pre-processing or pre-treatment node, we can extract the facial information using the YOLO model. Then, we can use the onVideo node to encode this facial information into the latent space. Now, pay close attention to this crucial node called onVideo Latent. This node essentially adds the IP latent to our regular latent. In the previous workflow, this part was left empty, or rather, it generated an empty image in the latent space, similar to empty latent space. But here, I've replaced it with the encoded vector generated by VACE. By doing this, we combine stand-in and VACE to generate a new image embedding vector. Then, it goes through our encoding process, which is straightforward. This means the output now contains both stand-in and VAC information, which is extremely important. For the prompt, I wrote, "A woman is talking." The sampling settings are basically the same as in our last lesson. Let's look at the final generated effect. You can compare the pose map with the final generated result. If we synchronize them, you can see a hand movement that transforms into a hair combing action in the output, which is very beautiful. The character consistency is also very well maintained. When using this workflow, there are a few points you need to pay attention to. 1. Selection of pre-processing model. I highly recommend using DW Openpose as the preprocessor. Do not use depth or canny. If basic control over the outline is applied, the effect cannot be guaranteed, and character consistency will appear weaker. For example, in one test, the workflow was identical, but the preprocessor was changed to depth. The reference video was an official stand-in example of a woman sliding her hand down, while the depth map excellently captured this action with outline information, making the character's outline very similar to the reference video. The facial features, despite resembling the reference image, made the overall character look less similar. This is why we advise against using depth maps. A pose map is sufficient. 2. Shot scale. In the application of the stand-in model, we explicitly emphasized that shot scale is very important. It excels at close-up or medium shot representations. Long shots will have issues. This characteristic remains even when combined with VACE. I have a reference video showing a woman being filmed as the camera moves from underwater to above water. A rather special shot, slightly on the wider side. We can still capture the pose very well. The final generated effect shows that both camera movement and pose movement are captured. However, if you look closely, you'll find that some character consistency is lost. While still decent, it's not as good as the performance in closer scenes. These are two very critical issues. If you pay attention to these 2 points, the quality of the videos you get will often be very high. Let's look at some final test examples. Here's a video of a girl with a very close-up facial expression. This feature is also reflected in her pose map. By combining stand-in and VAC, we get this effect. The expression is quite exaggerated. Because it's a close-up shot, the character consistency is excellent. Let's look at another example. The same reference video as before, but instead of a depth map, we're using a pose map now. You can see the facial features and poses are very well represented. We get a video that, although not a frontal shot and containing side view information, shows excellent character consistency, hairstyle, clothing, and movements. Next, a video of a woman painting. We also obtained her pose map. Since the shot is relatively close, the quality is guaranteed to be superb. Finally, a reference video of a woman talking. We similarly obtained her pose map. Combining this with stand-in, we get a very similar video. Because the shot is relatively a bit further away, you might notice that the face isn't quite as similar. While still very similar, it's not perfectly identical. This concludes our discussion today on the advanced application technique of combining stand-in and VACE. As you can see, when combined, we achieve even better character consistency effects and can control the overall posture of the character. What are you waiting for? Go ahead and try it yourself. Follow me to become someone who understands AI.